Hello everyone. So in today's video of chapter solution, I'll be talking about the last colligative property, osmotic pressure. Before starting osmotic pressure, let's aware with the term semi-permeable membrane osmosis. Osmotic pressure phenomena involves the use of semi-permeable membrane, and it is a film-like structure, or you can say it is a cellophane which has a pores large enough to allow the solvent molecules to pass through them, and these are the pores which are very, you can say, small enough and do not allow the passage of large solute molecules or ions of you can say higher molecular mass through them. The semi-permeable membrane selectively allow passage of solvent molecules. And what is osmosis? When a solution and pure solvent when a solution and pure solvent or two solutions of different concentration are separated by semi-permeable membrane, then the solvent molecule pass through the membrane, and the direction of flow of solvent is from the higher concentration area of solvent particles to the lower concentration area of the solvent particle. Until when it will take place? Till the concentration of solvent will become uniform on both the sides. It is important to understand that the passage of solvent molecules through the semi-permeable membrane takes place in both the directions, because solvent is present in both the direction, but the rate of passage of solvent molecules into the solution or from the dilute solution to the more concentrated solution is found to be greater than the rate in the reverse direction. This is favorable since the vapor pressure of solvent is greater than that of solvent. So the net spontaneous flow of solvent molecule into the solution from the dilute solution to the concentrated solution through some semi-permeable membrane is called osmosis. This is what is shown in this diagram. This is one container where the two kind of liquids, one is solvent and solution, is parted by semi-permeable membrane. So the solvent is flowing from its higher concentration area to the lower concentration area, or from solvent to solution. Or if you have taken two solutions which are parted with semi-permeable membrane and both are having different concentrations, or you can say different, one is concentrated and another is dilute. So there the solution of lower concentration area, you will see there is a passage of solvent particle from the dilute to concentrated solution, and the process is called as osmosis. And now, what is osmotic pressure? Semi-permeable membrane is firmly fastened across the mouth of the thistle bulb. Here, let's understand this first. This is one thistle funnel and the semi-permeable is fastened over the mouth, and sugar solution is filled inside the thistle funnel, and this thistle funnel is put into one container having water in it, and this inverted part of thistle funnel is immersed in the container of pure water. Now, what will happen? Some of the solvent pass through the membrane from container to thistle funnel into the solution. What will happen? This mercury solution, this solution will higher in the level. The liquid level in tube will rise. The liquid column in the tube creates hydrostatic pressure that pushes the solvent which is entered here in the thistle funnel back to the container. The column of liquid in the tube container to rise and stops rising eventually. At this stage, the hydrostatic pressure developed is sufficient to force solvent molecules back to the membrane into the container at the same rate the way they are entering, and Finally, one equilibrium will be established where the rate of forward and reverse passages will become equal and the height of the liquid in the tube will also remain constant. And this implies that hydrostatic pressure has stopped osmosis. So the hydrostatic pressure that stops osmosis is an osmotic pressure denoted by pi of the solution, and the hydrostatic pressure is equal to h rho g, where h is the height of the liquid in the column of the tube, rho is the density, and g is the acceleration due to gravity. Now, what is isotonic, hypertonic and hypotonic solution? Isotonic solutions are those where two or more solutions having same osmotic pressure are called isotonic solutions. For example, we have 0.1 molar urea solution and 0.1 molar sucrase solution, and they are having same osmotic pressure, so they are called as isotonic solution. Such solution have same molecular concentration but different concentration in gram per liter. If these solutions are separated by a semi-permeable membrane, so we will not see any flow of solvent from any direction. Hypertonic and hypotonic solutions. If two solutions have unequal osmotic pressures, then more concentrated solution with higher osmotic pressure is said as hypertonic solution, and the dilute solution exhibiting lower osmotic pressure is called as hypotonic solution. If osmotic pressure of sucrose solution is higher than that of urea solution, then sucrose solution is hypertonic and urea solution is hypotonic solution. Now, next topic is osmotic pressure and concentration of solution. For a very dilute solution, osmotic pressure can be calculated by pi equals to N2 RT upon V. V is the volume of solution in dm³, N2 is the moles of non-volatile solute, R is the gas constant, which is equal to 0.08206 dm³ atmospheric Kelvin inverse mole inverse. Pi is atmospheric pressure in atmosphere or osmotic pressure in atmosphere. And if I am removing the term N2 upon V by molarity, so my osmotic pressure will be represented as pi equals to mRT. If I want to calculate molar mass of solute from osmotic pressure, I can calculate by this formula. And if N2 is replaced by W2 upon M2, the formula would become pi is equal to W2R2 upon M2 into V. And after rearranging, M2 would be equals to W2R2 upon pi V. It should be noted that solute concentration is expressed in molarity while calculating osmotic pressure rather than molality. The reason is osmotic pressure measurement are made at the specific constant temperature, and it is not necessary to express concentration in a temperature independent unit like molality. Now, reverse osmosis. Now, what is this? We have learnt osmosis, that osmosis is the flow of solvent through a semi-permeable membrane into the solution. The direction of osmosis can be reversed by applying pressure larger than the osmotic pressure. The pure solvent then, after applying pressure, the pure solvent will flow from solution into the pure solvent through semi-permeable membrane, and then it would be called as reverse osmosis. Alright, now what I am going to do, this is the schematic setup for reverse osmosis. Fresh water and salty water are taken in two parts and parted by semi-permeable membrane, and when the pressure is larger than the osmotic pressure of solution applied to solution, the pure water from salty water passes to fresh water through the semi-permeable membrane, and the process would be called as reverse osmosis. Thank you.